Organizing your code is an important skill for every developer. It ensures that your code is easy to follow, that it has a logical flow, and it helps you so you don't get lost as you're developing more features. And it gets increasingly more important as you make your code more and more complex. When you make it more and more complex, it makes it harder for you to follow what's going on, and so organization is really key. Much like a disorganized house, when things are not stored correctly, it becomes harder and harder to find things when you've misplaced them. And furthermore, it becomes harder to maneuver around because there's so much clutter everywhere. And the worst part is that it becomes a messy site that you have to deal with on a day-to-day basis. In this video, I'm going to give a beginner's guide to organizing code, and I'll give you some general principles that you can take right away to apply on your next programming project. And lastly, I'll go through an example where we'll start off with some messy code, and then we're going to organize it together in a really nice and neatly organized code base. So my name's Henrik, and I'm here to help you learn the foundations of software development. So let's get started. But before we begin, I'd like to mention that I do have a free workshop for you. It's called my Capstone Project Workshop. And in that workshop, I go over 3 secrets to coding your own Capstone project in just 3 months. Now, why did I create this workshop? The most common goal that I get from people who apply to my one-on-one programming mentorship program is to, quote, be more proficient at creating projects. You and I both know that learning how to code is more than just memorizing code syntax. It's about applying your coding skills to real-world projects that make you feel confident and capable. So if this sounds like you can download this workshop in the link in the description. And if you download it and watch it and pay attention to what it says, then you'll definitely build a good foundation to your software development journey. Alright, so as I was thinking about the principles that I want to share in this video, the first one that I think is really important to organizing code is that you need to learn how to use Git. And if you don't know what Git is, it's just a tool that you can use to keep track of different versions of your code. So it's a version control system, and then here's a diagram here to help explain what it is. So basically what you have is like you have a initial code base here, and then as you make changes, you'll have different versions of your code. And these are called commits. And so every time you make a commit, or every time you make a change in your code, you can have a message that's associated with that commit. And that can be useful in the future because as you're coding, you'll eventually have a commit history, and then you can see all the changes that you've made through these comments that you've made, through these messages, these commit messages that you've made. The main benefit of using Git is that you can make incremental changes to your code so that you're making sure that you're developing your code in an organized way. And so say you have your initial code here and you're making initial progress over time. So you have these different versions and you're making incremental changes, so it's kind of like you're saving your progress over time. Another benefit of using Git is that you have what are called branches, and so you can actually work with a coworker or a teammate, and so you have this initial code base or version of the code, then you can make a change, and then your coworker or your teammate can make a change, and then over time your coworker or your teammate's code changes can come back into the main branch, and then basically your branch is always going to have everyone's code. Everyone's changes are eventually going to come back into this one main branch. This idea of saving your progress over time doesn't seem that important when you're making simple projects, but as you make more and more complex projects, it becomes really important. And one example of this is that it helps you solve some bugs. So say you have this initial version of your code, and then you coded a feature, and then you have this version, and then you've saved that version. So there's that idea of saving your versions. So you've saved your progress here, and then say you're doing more development, and then you come to this part of the code or this part in your development, and then you've coded a new feature, but then as you were coding that new feature, you didn't test this feature anymore, and you actually broke that feature. And so what you can do is you can compare this version of your code with this version and see how did my new changes affect this version of the code where that feature was working. And so as you make that comparison, it becomes readily apparent what was causing the problem that's happening that broke that initial feature. And the cool thing about Git is that you can actually revert to a different version. You can revert your current code to this version, and then you can do your redevelopment. So you can redevelop this feature that you're working on and keep an eye out so that you don't break this initial feature. Another nice thing about Git is that you usually host your code in a remote repository. And so you can have these repositories remotely, and basically they're hosted on this platform called GitHub. So this is GitHub. If you haven't heard of it yet, this is where you can use Git, and then you can host all your repositories, all your projects here. So I have different projects here, and then you can look at the projects, and then you can see here all of the code that you've written for this project. And so you have a repository for each project. You can look at the commit history here. And then there's a commit history. There's only one commit in this branch, but then you can have other branches too. So I have Alice discount and Bob tax. These are different branches of, this was an example I did before on how to merge conflicts. And so you can see all of the history, all of what everyone is doing in that code base. You can see it all here on the internet. And then say you're done with a project, you can actually delete it from your local machine, given that you have a remote version that has all of your changes in a repository online. And then whenever you want to work on it again, you can just do a git clone of this repository and then work on it again. If ever I want to look up some tutorial that I've done in the past, I can just go here and just look at all my projects. And so you can see how organized this is. All right, so now here's where the fun starts. So what I'm going to do is I have this project here. I have this code here, this program. And basically what it does is it acts like a banking system where you can check your balance, you can deposit money, withdraw money, and then exit. And then basically it does whatever the user says given the number here. And let's run it and I'll show you how it works. All right, so banking system, check balance. I want to check my balance. Your current balance is 1,000. Okay, I'm going to deposit money. How much do I want to deposit? I'm going to deposit 1,400. Okay, deposit successful. New balance is 2,400. Now I want to withdraw money. I'm going to withdraw 500. Okay, now my balance is 1,900, and then now I'm going to exit, so 4. And so there you go. So I have this program that works, but the problem is that it's kind of discombobulated, or it's kind of messy. Well, it's actually not that messy because it's a really simple code. It's only 66 lines of code or 67 lines of code. But I'm gonna go through an example of how to organize this code. So the first thing I want to do is I want to create a repository for this banking system. So I'm going to go into GitHub. I'm going to do new. I'm going to create a new repository. And then I'm going to call it banking system. Make it public so you can actually access this if you want. And then create repository. Okay, so I have this banking system repository. Now I need to clone this repository in my local machine. Okay, so I've navigated to my GitHub folder on my machine, and I'm just going to do git clone. Then I'm going to go back to GitHub and get my git repo URL. So copy that. Okay, then I'm going to paste it here. Okay, now it says I'm cloning this repo. I've cloned an empty repository. All right, now I'm going to move that file that I showed you earlier into this folder. So I can go to banking system, and then if you do ls, you can see there's nothing inside. So I'm going to put my file in there. Okay, I put my file in there. You can see it there, bankingsystem.c. I'm going to add it to my repo. Then I'm going to make a commit message. I'm going to say add initial banking system code. Then I'm going to push it to my remote repo. Okay, so I've created this new branch called main, and then let's go back to GitHub. Okay, so I reload this, and there you go. There's my banking system.c, and then it says here, this is my message, and then you can look at the commit history, and then this is the commit. And then if you open this one, you can see what that change was. It was basically I just created this new file, and I added all of these lines of code. And it says who committed it. I committed it, Henrik. So you can also click on this and see the file. So this is the file that I added. And so now let's organize it. And as we organize it, we can make more commit messages to organize it. The first step usually when it comes to organizing code is you want to find where you can put some code into a different function so that everything is not under this main function. So you can split up your main function into other smaller functions, and so you can make your main function more readable. So let's go ahead and do that. All right, so now here's a version of the code where we split the main function into smaller functions here. So we have a display menu function, a display balance function, deposit and withdraw function. So we call those functions here, display menu, display balance, deposit, and withdraw. And then the functions are defined at the bottom. So here you can see the functions displaying the menu, displaying balance, handling the deposit, handling the withdraw. So let's just run this and make sure it still works. Okay, your current balance is 1,000, deposit money, gonna deposit 2,000. Now your balance is 3,000, withdraw money. And then I'm going to withdraw 500, and now my balance is 2,500, and then 4 to exit. Okay, so it still works. Now the next step so that's your first tip. This first tip is to split up your main function into different smaller functions. Now let's go a level deeper in organization. So what we're going to do is we're going to actually move these functions into different files. Okay, so now I've split this code into different files, and if you're confused as to how do you find out or how do you determine what kind of files to create, basically you just create files according to different themes in your program. And so for this example, a common theme or a theme that we like to give to beginners is to split your program into what are called UI functions and then logic functions. And so we can go to bank.h. And so we have these UI functions that are just for the UI for displaying stuff, displaying menu, displaying balance. Then we have logic functions to display like the deposit functionality and the withdraw functionality. And so now we put these two functions, the display menu and display balance, we put it inside the UI.c. So I have this UI.c file that has the display functions. Then we go back to bank.h. So now we have the logic functions, deposit and withdraw, and then we put it in the logic.c file. So in here we have the deposit and then the withdraw. And then they're all including this bank.h file. So this bank.h file is a common header file that has all of the functions prototypes here, and then bankingsystem.c is just going to include that one, and so that's how it's able to call these functions here. And so now you see in our main banking system.c, this file is a lot cleaner. It's a lot smaller. It just has everything here. And if it's your first time reading this code, you can look at this and you already know what's going on. And then if you want to know, okay, what is deposit? Okay, let's go to the logic function here and then see what does deposit do. So you organize your code according to different themes in your program. I also have this makefile here that compiles the different C files here. So we have banking system and then logic and UI. So we compile them based on those C files, and then we create object files. Then we combine them together into this banking app executable. Okay, so I'm going to run this makefile to compile all of our different files into one executable. So let's run this. So you just do make. Okay, so it shows all of the things that we compiled, and then it compiled them into this banking app. So let's run this banking app executable. Okay, let's check balance 1. Okay, 1,000. Okay, deposit money. Let's deposit 3,000. Okay, 4,000. Withdraw money. Let's withdraw 500. Okay, now 3,500, and then 4 exit. Okay, so now it still works. And now what we can do is we can actually, let's commit all of these changes to our repository, because this is good progress already. So let's go ahead and do that. So we can do git status here. You can see the files that are untracked. So we want to make sure we track all these files. We don't want to track the O files, just the .c files, the logic.c, UI.c. And then we want to add this change we made to the main file. So let's add. Yeah, I created a README here to describe the changes or to describe this file system for this project. So we have bankingsystem.c, which is the main program. We have bank.h, it's a shared header file. Logic.c handles deposits and withdrawals. UI handles menu display and UI interactions. And then makefile, which automates the compilation. So let's continue here. Let's check what else we need to add. We need to add the README file. Okay, these are the only files that I care about. These are all generated files here. Git push origin main. Usually you don't just commit to the main branch. Usually you make a branch and then you make your changes, commit your changes there, and then if everything's all good, you merge that branch into main. But for this video, I'm just going to commit directly to main. Okay, we're back in GitHub. Let's go back to the banking system. Okay, now we see all of our files. We see the README here, this README that I created, and then you can look at the logic. This is our logic files, our logic functions, banking system, .h, and then UI functions, logic functions. Good. Now, speaking of the header file, this is another way that you can organize your code by creating a header file. And I kind of did this already in this previous step, but this is another thing I want to highlight is that you want to create a header file for your main function or for your program. And so what you could actually do is you can store the function prototypes here, but you can also store some pound defines. So any constants that you have in your program, the header file is also a good place to put that. So looking back at our code over here, we actually have a lot of hard-coded values like this balance here. We have this hard-coded withdrawal attempts max limit. And then what else? We have some hard-coded values here for max deposit and min deposit. So a good way to organize your code is have a pound defined, a constant that's defined for these, because say you have other features that you want to do in the future and they also use these same exact numbers. You don't want to change these numbers every time you change that the max deposit number. You want to just change the constant, and then that way you just change the constant and it reflects throughout your whole code base. Every time that there's some code that uses that number, then you only have to modify it in the header file here. Okay, now I've created some pound defines for the constants: min deposit, max withdrawal attempts, and initial balance. And you can see them here in banking system.c. There's the initial balance and then the max withdrawal attempts here. And then in the logic function we have, or the logic file, we have min deposit, and then max withdrawal here. Another thing that's nice about having your code split up into these different files is that you can actually use these files in different programs. So if you want to do some unit tests, if you want to test the deposit functionality, make sure it's working, then you can actually create a unit test that just pulls in this file, this logic.c, and then you'll have to pull in this bank.h because the prototype is there. And then you can actually use this function, do your testing with this function, make sure it's actually working correctly for different test cases. Same with withdraw, and then yeah, so this is really good when you want to create some unit tests. And so usually you would put your unit tests in this file system also. The last thing I'll say about code organization for beginners for this beginner guide is you also want to make some comments and some documentation. So you can have a function here, deposit, but you also need to have some sort of description of the function here. And this is really useful for teams. Like for me in my company, a lot of times I see a function and I don't know what it's doing. So I usually refer to the description or what's above the function, the description, the header of the function, just to look at what kind of comments did the previous developer make about it. And so you can learn some really important things about the code through that. And so likewise, when you're organizing your code, you want to do the same thing. So let's do that. Okay, so I added some comments here. These are constants for transactions, UI functions. This displays the menu options to the user. This displays the current balance with the param balance, the current balance in the account, and then this is for deposit. Deposits an amount into the balance, has these parameters balance and amount, and then it returns the updated balance after deposit. Withdraw has these parameters. Withdraw an amount from the balance considering withdrawal attempts. So balance, the current balance, the amount to withdraw, pointer to track the failed to track failed withdrawal attempts, and then return the updated balance after withdrawal. And then we also have also a comment here for main function that drives the banking system. Users can check their balance, deposit, withdraw, or exit. Withdrawal attempts are limited to max withdrawal attempts. All right, so now we have a lot more. Now the code is a lot more readable. It has some descriptions here, and like I mentioned earlier, like I showed you earlier, the README is also good to give someone who's looking at this code for the first time. It would be good to have this README so they can readily see what are all the files doing in this code base. If you see here on the sides, there's M, there's U, M. That just means that we've modified these files ever since we had committed our last commit. So after our last commit, we had changed these 3 files here. These files are still uncommitted. We didn't put them in the repo. And then these files are untouched. And so I guess that's another bonus tip. Another good tip is to use a IDE or use an IDE. So now let's go ahead and add these 3 files because I made those changes to those files. So git status. Okay, now it says modified. So I'm going to add those modified files. Okay, I've added those changes. Now let's commit. Okay, I'm gonna push to main. Git push origin main. Okay, let's reload this. Okay, so there you go. It has all of the changes I've made, all of the descriptions. Let's go to the main function, banking system.c. So this is our main function. It has our description of the main function and then everything that we're going to do. And so you see the code looks a lot more organized. The last thing I want to do is I want to add a git ignore file to ignore these files here, because I don't want to keep seeing U here. And then every time I do a git status, I don't want to see all of this stuff here. So I'm going to create a .git ignore file. Oh, that's cool. I saved it here and then you can see it the U disappeared here. Save. And then, oh, that U disappeared. I can also just do a star here. Okay, now there's only one U now, which is this .git ignore. Oh, there's VS Code up here. I can ignore that too. Okay, now we just have this git ignore that's not added yet. So if I do a git status here, now it only tracks this file here that I just added. So now my git repo is ignoring those intermediate files. And now this looks a lot nicer in VS Code. And also when I do a git status, I don't see any of those miscellaneous files here, but there's those intermediate files. Okay, and then there's the .git ignore there. All right, so there you go. I organized the code for you. I gave you some tips on how to organize your code. So after, you can actually go back to your previous projects. If you've only been using one file for all of your projects, you can use these principles here to organize your code. I think this is a good skill to develop. This is good practice so that when you develop future projects, you can code and organize your code in a way and make your code readable and easy to do some more development on. Like I mentioned earlier, I have a free workshop for you, my Capstone project workshop. And in that workshop, I go over 3 secrets to coding your own Capstone project in just 3 months. So if you want to become more proficient at creating your own projects, you want to move on from these tutorials and create your own projects, then be sure to check the link in the description and watch my coding workshop today. All right, that's it for this week's video. I hope it helped you out and learn how to organize your code. And if it did help you out, please like, share, and subscribe to the channel. And if you have any other questions, feel free to let me know in the comment section and I'll be sure to answer you there. And I'll see you in the next one. Peace.